Let's start by drawing a free body diagram of this situation. So here's you. Okay. Here's your mittens. Here's your snow pants. And here's the boots in question. And here's our ice. Okay. So some forces acting here. One is the force of gravity pulling you down. Normal force, that should be the same length, I'm just running out of room. And if you're moving kind of this way, that means that friction is fighting the motion, slowing you down. You may feel like there should be a fourth force because you're moving forward, but actually because you're slowing down, it's just really the friction that's acting here. So we know a few things. For one, they told us the weight is 100 newtons. So remember, weight is equal to the force of gravity. So we have 100 newtons here. And since force of gravity is always equal on a flat surface where you're not moving up or down to the normal force, those two cancel out. Okay. So when they ask you for what the normal force is, there it is, right in front of you. Okay. What is the force of friction acting on you? All right, so we're going to have to do some math with this. So if you remember force of friction, we can write it like this. Force normal times mu. Okay. We know our normal force. We found it here. And they gave us the mu, that coefficient of friction. Okay. They said it was 0.15. So force of friction is equal to 100 times 0.15. And I get force of friction is equal to 15 newtons. The next part is a little bit trickier. What is your acceleration? Well, there's only really one equation where force and acceleration are related that we use a lot, and that is F net is equal to mass times acceleration, so your net force. Now, gravity and normal force are going to cancel each other out. So that means if we want to find the acceleration, we're going to need to just be using our frictional force. That's the last force left. So this guy's going to be 15. We found him before. It's the force of friction. We don't know the mass. That's tricky. But remember that every time you know the force of gravity, you also know the mass. You can find that by using Fg is equal to mg. So 100 is equal to, the mass is what we're looking for, and g is 9.8. That gets us a mass of 10.2. Okay, so now we can put that back in here. So F net equals 10.2. Oops, should just put in my F net, which was okay, I know my F net was 15 newtons. It was that force of friction. So 15. So our acceleration is 1.47 meters per second squared. The last question you can solve by using things, using our constant acceleration equations. So you can go A equals VI equals VF equals D equals T equals. And let's write down some of the things we know. We know the acceleration. We just found it. It was right here, 1.47. We know the initial velocity. The problem gave it to us. It was 4 meters per second. We know V final is 0. And they're asking how long will it take you to stop. So you can put a question mark. If you don't know any distance, you're going to have to choose an equation without distance in it. So you're going to use A is equal to VF minus VI over T. And you can solve from there. All right, hope this helped. Have a nice day.